Hey guys, let's get started on 6.4. I'm hoping you guys are doing well on 6.2, 6.3, and the main premise is you need to use that calculator and be comfortable with it because it will help you. So let's go ahead and look at it. So let me go to my slideshow. Okay. So we're looking at finding values of the normally distributed random variable. Okay. All right. I broke this video up into sections. So here we go. Finding the z-value with a given area to its left. Okay. Finding the z-value with a given area to its left. What z-value has an area of 0.7357 to its left? All right, before we never had to do that. We were only using the z-score to find the area. Now we have the area. Now we need to look for the z-score. Okay. We know it's going to be positive because 0.7357 is greater than 0.5, so we know it's going to lie on the right of the mean, so the z-score is positive. If we draw it out, this is what it would look like. So we're looking for that z. So we can look it up in the table, go into the middle section, and you see 0.7357. And if you go to the first column, you see 0.6, and if you go to the first row, you see 0.03. Put those together, it's 0.63. But there's actually an easier way to do this, and let's look at it in your calculator. So if you're going to go second, bars, B-A-R-S, and it's right next to the clear button. Go to 3, parentheses, 0.7357, close parentheses. If you do that, you're going to see 0.630144569. All you need to give Hawks is 0.63 because that's the z-score. We saw it on the earlier slide how to see it in the table, but now we actually see it as how to use the calculator to get it. Okay, let's do another example. Find the value of z such that the area to the left of z is 0.2000. All right. Let's compare it and let's think of it as a graph. 0.2000 is less than 0.5, so our z-score is going to be negative. We see that here. Again, we could look it up into the table, but let's go ahead and use that calculator. That's going to make our life so much easier. Second, vars, 3, and we're going to put 0.2000, close parentheses. And look what you get, negative 0.84, which our z-score then is negative 0.84. So that tells us that under the mean, this is 0.84 standard deviations away from the mean. All right, this is a little different. Let's see this. What z-value represents the 90th percentile? So the 90th percentile is the z-value for which 90% of the data lie to the left of it. So we're going to look for the area of 0.9000 to its left. So here's a picture of it. We can look it up in the table, but if you look it up in the table, let's look here. We don't see a 0.9000. We see a 0.8997 and a 0.9015. Well, if you're using the table, go with the one that's closest to it. So that would be 1.28 because 0.0013 compared to 0.0015 is smaller, so you want the smaller amount. Or use your calculator. Second, var 3, 0.9000, close parentheses, and you get 1.28. So your z-score is 1.28. So, areas to the left. It's the inverse norm function. So second bar 3, put the area in there and solve, and it gives you your z. Okay, so let's do for areas to the right. What z-value has an area of 0.0096 to its right? Okay, I'm going to flip to the next slide to show you. So if you have 0.0096 to your right, what do you have to your left? Well, you actually have 0.9904. Because if you subtract 1 minus if you subtract 0.0096, you get 0.9904. Because remember, the area under the curve will always equal 1. Okay, well, we could look it up in the table and do the 0.9904 because all we're doing is really looking to the left to see what we get. We get our z-score of 2.34. Let's do it in the calculator. This is easier. Areas to the right. Second, bar 3, and now we're going to do 1 minus 0.0096, close parentheses, 2.34. What is the difference between this and the left? We just added that 1 minus to account for this going to the right as opposed to the left. All right, so let's look between two values. This is different, okay? So let's do find the area of z such that the area between negative z and c is 0.90. All right, let me go to the graph to explain this. So I'm saying between that negative z and that c, I have 0.9000. Well, I have two areas in yellow. So to get the actual area in yellow, do 1 minus 0.9000, and I get 0.10. Divide that by 2 because I have two tails. One to the left of the mean, one to the right of the mean. If you do that, you get 0.05. So, what am I going to look for? I'm going to look for 0.0500 because all it wanted me to look for was the positive z-score. Well, we can look it up in the table, and this one's kind of weird because it falls between two values, negative 1.65 and negative 1.64. So, you average those together and get negative 1.645. So, but let's look at it with the calculator. So do second var 3.05. Okay, where was that 0.05? Remember, that was one of the tails. So if I hit enter, I get negative 1.64. Our negative z is negative 1.645, and our positive z is 1.645. Make sure to see what they're asking for in that question in Hawks, because they might be asking for the negative or the positive. Excuse me. The following slides are for areas dealing with the tails. So it's going to ask you, find the z value with a given area in the tails to the left of negative z and to the right of positive z. All right, they have to tell you that's what you're looking for. So those problems are kind of easy because you have to know its tails. So find the value of z such that the area to the left of negative z and the area to the right of z is 0.1616. So I know it's tails, that means there's two of them. So I divide that 0.1616 by 2 and get 0.0808. So we don't know anything about that middle yet, right? All we know is the area of the tails. Well, we can go look that up in the book. If we look it up in the table, we get it's negative 1.40 for the tail to the left of the mean, and we get 1.40 to the area of the right of the mean. This table in the book, table A and table B, one z-score, like if you see negative 1.40 will give you your amount. But if you went and looked at a positive 1.40, it's going to be a different amount. It's going to be 0.9912. And why that is because if I took both areas of the negative and the positive z-score for one value, such as negative 1.40 and positive 1.40, it's going to equal 1 because I'm taking into account the part to the left and the part to the right. Okay? So let's keep going. All right, I want to use my calculator. So I'm going to do second bar 3.1616 divided by 2, because I'm just going to go ahead and let the calculator do the work. All right, find me that tail. And I get negative 1.39. Well, I'm going to round that up to 1.40, and that's my answer. So the positive value for z is 1.40. All right, here's another one. If a normally distributed has a mean of 28.0 and a standard deviation of 2.5, what is the value of the random variable x that has an area to its right equal to 0.6700? All right, Huge key right here is right. So remember what we could do. We could do second var 3, 1 minus 0.6700, close parentheses, and I get negative 0.4399. So I'm going to say it's negative 0.44. But I have to use that to solve for the equation. So if you look at this equation, this is actually the z-score formula, but what we did is we solved it for x. So when you do that, you're going to have the z-score times the standard deviation plus the mean. And if you do that, you get 26.9. Because I had an area, I had to solve for my z-score, and now I can solve for x. But there's even an easier way to do it with a calculator. Let's look at it. Okay, here we go. Second var 3. Okay, we know we're going to do the inverse now. I'm going to do 1 minus my area, right? 1 minus, 0.6700, comma, 28.0, which is my mean, comma, 2.5, which is my standard deviation. Close those parentheses, and you get 26.9. So what is that formula? You're doing the inverse norm with your area first, comma, your mean, comma, your standard deviation. Let's do another one. The body temperature of adults is normally distributed with a mean of 98.6 degrees Fahrenheit and a standard deviation of 0.73 degrees Fahrenheit. What temperature represents the 90th percentile? We did this earlier and we found that 90th percentile is 1.28, but let's do it with the calculator. Okay? This will make our life so much easier. So because we're okay with it being to the left, we do not have to do 1 minus the area. So we're going to do a second var 3, 0.90, comma, the mean, 98.6, comma, and the standard deviation of 0.73. Close those parentheses, and you get 99.53. All right, keep working on these and let me know if you have any questions, and I'll be more than happy to help you. Have a good one.